So I wanted to show you how to get the normal line after finding the tangent line or the equation to the tangent line for this particular function, as it's not really illustrated in the book, and it was probably something we learned back in 111 or earlier algebra. So the first thing is let's do what we know how to do, which is go ahead and take the derivative of this function. And of course, to get the equation of the tangent line, we're going to need two things. The first thing we need is the slope of tangent. And the second thing that we'll need, of course, are given, which are the points, or the point, x and y. So the first thing is we'll go ahead and set this up to take the derivative. So we'll have the derivative with respect to y, or derivative y with respect to x, excuse me. And we're going to take the derivative of x to the fourth plus 2 times e to the x. And we'll go ahead and split this up so you can see how this operates individually. We're going to use the sum rule. So we will have x to the fourth plus, we'll take the derivative separately, of a constant times, well, e is a number, to x. And first, x to the fourth, that's going to be 4 times x to the fourth minus 1. And for this other one, we'll go ahead and just separate this out. So we'll take a constant out, and we'll say that this is plus 2 times the derivative with respect to x for e to the x. Well, we learned that this natural e to the x, when we take the derivative of it, it is that unique function that it is simply e to the x. Therefore, we can say that we have a derivative equation, a derivative function that is 4x to the third plus 2e to the x. So from here, we need to create the equation of the tangent line. And actually, before we do that, let's go ahead and figure out what our slope is. Since we do have the derivative function, we need to figure that out, and we're going to just plug 0 in to our function. So we will have m tan representing slope of tangent. Our input will be 0. So we will end up with 4 times 0 to the third plus 2e raised to the 0 power. And of course, 0 to the third is 0, and anything times 0 is 0. So this is gone. We're going to end up with 2e to the first. Well, e to 0, I'm sorry, not to the first. E to the 0 is just that's going to make this just 1. So really our slope is 2. So that's what we end up with. So I'll put that up there. And now that we have our slope, we have our points, they were given, we can go ahead and create the equation of the tangent line at point 0,2. So we will begin with point slope, which is y minus y1, which is equal to slope of tangent multiplied by x minus x1. Go ahead and plug in our values that were given for the point, and we'll have y minus 2 is equal to our slope. Well, we said our slope is also 2 times x minus, and that's minus 0. So this is our tangent line to the curve. So over here on the left, I have the graph of this function's curve, and I also have 0,2 illustrated as a point. And what we're trying to do is create some line that passes and just barely touches, just kisses that little point right there. So just barely touching it. So that's what we're looking for, and this equation that we just found should do that for us. So now they're asking to find the normal line. And in order for us to do that, there's just a very simple rule that once you have the equation of a line and you want to find the normal line, what they're asking for is just simply find a line that is perpendicular at that point. And the way we do that is extremely simple. We take the slope for that point, and we said that our slope is 2. To find a perpendicular line to the point 0, 2, all we will do is we will say that the normal slope, and I'm really not sure how to notate that, so I'm just going to call it M normal. And we're just going to take this 2, and the first thing we're going to do is take the reciprocal of 2, which is 1/2, and we're going to add a negative sign. But it's not always negative. I just want to let you know that we're actually taking the opposite of whatever the inverse of the slope is. Meaning, if this had been -2, we would end up with -1/2. Then we take the opposite of that, and it would have been a positive 1/2 slope. So really, we're taking the opposite in order for us to end up with a perpendicular line at that point. So the equation itself for a normal line at 0, 2 is going to be exactly the same as what we found for the tangent line, except for the slope. That's the only difference. So we will say that our equation for the normal line is going to be y minus 2 is equal to the opposite and inverse of the slope. So opposite and inverse times x minus 0. So I went on Desmos and pulled those up so you can see what we did. And on the left, as you can see, this green line, this is the tangent to the curve, the tangent line to the curve at point 0, 2. When we took the opposite and inverse of the slope, that created this secondary line that is perpendicular to our tangent. It also passes through the point 0, 2. And that is all they are asking you to do in the homework. So hopefully that helps. Thanks for watching.